Hello and welcome to another frequently asked question video. In this one, we're going to be talking about this art up here, which kind of looks like a GitHub commit graph, but that is not what it is. It is some computer-generated art using a project that I wrote a very, very long time ago. I'm going to walk you through that project as well as this specific rendition and how I got to this, as well as some other interesting things that you can see if you peer into files. Anyway, let's jump into that. Oh, actually, before we jump into that, the entire project was originally inspired by a hackathon when I worked at Yelp called Color Code, and this was the logo theme T-shirt of the hackathon. And my girlfriend at the time and I were like, "Oh, I wonder if we could, generate something like this in code. That would look pretty cool." That was Hackathon 19 called Color Code, and that's kind of the inspiration for a lot of what ended up here. So we made this project that we also creatively called Color Code, and the idea was to take the bytes of any file and convert them automatically into art. And we kind of had two different versions of the art, one where and it generates some really cool looking stuff. One where the widths were variable, and one where the widths are constant. And you can kind of see, this has a bunch of black squares, but you can see eventually you get kind of these pretty and abstract art looking things. And so this was the project that we made. And the way it works is very, very simple. It basically just takes chunks of bytes out of a file and reinterprets them as colors, and if it has widths, it interprets it as widths as well, and renders a bunch of divs based on that. So we can actually look at the code here. Basically, yeah, read a triplet and turn it into a hex code, and if we're doing widths, read another byte and add 20 to make a width. And that's it. That's basically how this project works. It's fairly dead simple and generates some kind of cool looking abstract art. But the other thing that we noticed when we did this is some of the regions of our art look pretty different from others. Let's actually get, this file will work. So you can see how the colors here are relatively vibrant, and they're also fairly well distributed. So they're not all clumped. They don't all look very similar. They're very different. And this is echo. This is bin echo, which is basically just a binary file. And this is probably part of the program part of echo, where it's doing some amount of code. If we scroll way down, you can see here's a region that's fairly uniform. Don't know what this region is, but there's probably something about that. But I do know what this region is here. And you tend to see this pattern of colors whenever you're looking at a file. It's kind of dull. They're not really that vibrant of colors. They're certainly not like this. This is a strings region of the file. This is where inside the binary there is some amount of ASCII text that tends to show these kind of muted grays and dark colors. Actually, maybe it might be lower than this. So usually they're even darker. Here's another chunk that looks similar to that. Actually, no, that was probably it. That's probably the string section. You can see it a lot better in this binary because this one's a little bit smaller. So code section, and then somewhere down here, yeah. Then you get this string section with these same muted colors. And the reason for this is ASCII text, the typical boring English text that we see everywhere, happens to fall within a particular range of numbers between 0 and 127. And so it tends to not have 127 to 255, which is where you're going to get those more bright, vibrant colors, but it tends to be those duller, grayer colors. You can see this if you look at a file that's just pure text, such as faster.py. This is entirely ASCII text, and so you're going to see these gray, muted colors. So that's just kind of a cool thing that you can notice by peering at files like this. There's another one that's kind of interesting. I think it's this one. Zoom this in really far. Change the size of this. Come on, it's gonna line up. Oh, almost. Come on. Oh, why didn't it line up? So close. Anyway, this is the precommit.com favicon. And so this is a .ico file. You can kind of see it here. It's actually rendered upside down because that's the way the image renders. But this is the logo for this website here. So it's basically this P, but you can kind of see, that's not the right one, this one. You can kind of see the rectangle, and if I would have gotten the proper width, it actually shows the logo directly upside down and slightly tilted, and it's kind of cool. So you can kind of visualize how files go. But that's not what I want to talk about today. I want to talk about this one that I generated. This is the one that's up on the wall, the exact same one as that one, and it actually uses a completely, a very similar approach to this, but a kind of completely different algorithm. So what I wanted to do is have a monochrome version of this color code and basically have it fade between black and a vibrant color. And you know, I picked the shiny Umbreon's blue color for this, and so kind of have a contrast between them. But when I initially just picked random numbers, I kind of got this like mumbled garbage. Like it was a lot of these middle colors and not so much these bright and dark colors. So it was kind of just mud. It didn't really look that good. So what I did instead is I generated random numbers using a special distribution. Actually, I did a drawing of this on stream, so I will show you that drawing again on my A2EC Paint Twitter. So what I did is I generated a normal curve of random numbers to kind of get a good distribution. However, the normal curve has the opposite of what we want. It has everything in the middle and not so much on the edges. What I wanted is most of them to be on the edges, so we get lots of bright things and lots of dark things and not so many of these intermediate ones. So what I did is I took the normal curve and I flipped it. So I basically generated this blue region as the numbers that I picked. And so this is kind of what I ended up with. And then I used a bit of color math to multiply this scalar by the blue color. So I get everything from black to this particular blue, and then plotted it with the same color code as before. And so that's how I generated this. And yeah, it is not my GitHub my GitHub contribution graph. I feel like that would be a little bit boring because it's a little bit uniform besides auto update Mondays, but also I don't know, maybe a little too self-patronizing. But anyway, that's color code. That's the generated art that I have up on the wall, as well as how I went about doing it. Hopefully you enjoyed this, and I'll see you around the next one.